Let's create a standalone React project with NX. Now, NX is typically used for monorepo workspaces. Normally, you'd see multiple applications located in an apps directory of your workspace, and libraries that might be intended to be shared between those applications would go in the libs directory. A standalone workspace is a workspace designed to contain only a single application. In these workspaces, rather than placing our application into an apps directory, we instead hoist that application up to the root of our workspace. If we want, we can still break out sections of code of this application into libraries, but instead of those libraries living inside of a libs directory, we can hoist them up as well so that they exist simply as directories nested inside of our root application. In the rest of this tutorial, we'll create a workspace using the React Standalone preset that NX provides us and create some initial functionality so we can see how to use NX to get the most out of our workspace. We'll start out in our terminal and create our workspace with the command npx create NX workspace at latest and then give it the name store. If we just use this command, the script will prompt us as to which preset we'll want to use, and we'll select Standalone React here. Since I already know that this is the preset I want to use, I can also cancel out of this script with Control-C and rerun our original command, but add on the option --preset equals React-standalone to select this for us. Once this is done, I'll select CSS for our styles, and I'll also accept NX Cloud. And NX will go ahead and download all of our dependencies, and it'll also go ahead and scaffold the initial application for us. Once the script is complete, I'll cd into store. Remember, this was the name we gave to our workspace, and I'll open up VS Code here. With VS Code open, we can see that our project has been fully set up for us with most of the tools we'd want. Notice we have config files generated for ESLint for linting, end-to-end tests with Cypress inside of the E2E directory, Prettier for formatting, and Vite for bundling, and vtest for testing. Now, an NX workspace exists as a graph of projects. And we can see this graph if I right-click in the File Explorer and click the option here to open the NX graph, which is a feature of the NX console plugin that I have installed. Since we used a standalone React preset, we'll notice that a project.json file exists at the root of our workspace with the name store. This project.json file at the root of our workspace informs NX that all files by default will be a part of the store project, which is what we want for a standalone application. But notice how there's also an E2E node in our graph. If we open our E2E directory, we can see that this directory too contains a project.json file with E2E as its name. This will inform NX that the E2E directory is a project itself, and all files inside of this directory belong to that E2E project. Notice, for example, how our source directory does not have a project.json file, so we know it belongs to the root store project. Since we're using NX, we can also tap into NX's code generation. For example, we can create a component called shop in the root store project by running the command npx nxg component shop. Notice we didn't provide a project in this command, but if we look in our nx.json file, our default project is specified here as the store project. So NX knew to create this component in our store. Notice that this generator is scaffolding not only a TSX file for the component, but also a module.css file and a spec.tsx file, which can be nice for maintaining consistency in our workspace. It also sets up testing for us automatically. We can also use NX to generate other project nodes to further organize and scaffold our workspace. For instance, we can run the command npx nxg library cart. This will create a cart project that will later hook into routing at the root of our application. And npx nxg library shared/UI will create a project of shared UI components, like a banner component, for example. Because we use the slash inside of the name, we can see that the UI project is nested inside of a shared directory as well. Also note that each of these directories contains its own project.json file, which is how NX will know that these projects are self-contained projects and not a part of the standalone store project. If we inspect our project graph now, we can see all 4 nodes inside of our graph. Let's add some code to connect our projects. We'll start by installing the React Router DOM package by running the command npm I React Router DOM, same as we would in any other project. And now we'll configure our routes in the app.tsx file and import and add the browser router inside of our main.tsx file. Next, we'll create a simple banner component inside of our shared UI project. We could use the component generator that we saw earlier, but we can also just create a banner.tsx file here inside of the File Explorer, create our file here, and then export it from our project's index.txt barrel files so that other projects can import it and use it inside of their own source code. Now that it's exported, we can go into the cart component in our cart project and import the banner project here. And I'll also add a link here to continue shopping that will link back to the root route. Next, we'll we'll also add our banner component to our shop.tsx file and add a cart route to our routes in the app.tsx file. If we inspect our graph now, we can see that NX is now aware of the way our projects depend on each other, and this is based on the imports that we just added inside of each project source code. The visualization itself is actually helpful, as we can now see how our projects depend on each other, but NX will also use this information to help us build dynamic task pipelines, as we'll see later on in this video. But first, let's take a look at task running inside of NX. Those project.json files that we generated includes a property for targets, which will define all tasks that NX can run for that given project. Taking a look at shared/UI/project.json, for example, we can see that a build, lint, and test target exist. The executor property here is specifying an NX executor. The syntax we use is the name of the plugin here at narwhal/v, and then a colon, and then a name of the executor, which here we use build. The outputs property here is informing NX what files will be generated by this command, if any, so that NX can include those outputs in its cache for the task. Note that the outputs here for the build target are pointing to the value contained by the options.output path that we see right below. The options property here allows us to parameterize this executor, and if we have the VS Code plugin installed, we can use IntelliSense using control.space to bring up a list of all the options supported by the narwhal v executor. So we can see all of the options that we could set here if we wanted. To build the project, we can run the command npx nxbuild shared UI, where build is the name of the target and shared UI is the name of the project. I can open up a terminal and run this command myself, but since we have the NX console plugin installed, I can also just click this button right here, and that will open up a terminal and run that command for us. Notice that as long as I don't change the project source code, NX caching will step in if I try to run this build again, and it completes nearly instantly. Just for fun, I'll remove the dist directory here from the File Explorer view, and I'll hit the button one more time, and we can see again the command completes instantly, and if we look at our File Explorer, the dist directory is now back, and this shows us that our build has effectively been retrieved from the cache. Similarly, we can lint our project using the command npx nxlint shared UI, and as we can see, this is cacheable as well. Now that we understand how to run tasks, let's try running the build on our store application. To do this, we can run the command npx nxbuild store. But as we saw before, since the default project is set, I can remove the name of the project if I want and simply run the command npx nxbuild. Notice that before we actually start building the store application, we first read run project from cache, and then build a second project, and then we start building the store application. If we look at the nx.json file, we can see that this is because the default behavior of our build targets is to depend on the build of all targets that it depends on as signified by this caret character. This means that we will either retrieve dependent builds from cache, like with the shared UI project, or run a fresh build of it if it's not been cached yet, like with our cart project, before then running the build for our store application project. Now, if we run the build again, we can see that all three projects will now be retrieved from cache, and the command will complete instantly again. This way of configuring task pipelines is especially valuable as we consider that instead of manually creating a pipeline, we actually define to NX how a pipeline should be created based on the dependency graph that NX is dynamically maintaining. So essentially, NX will now manage our pipelines for us dynamically, which will allow us to scale this pipeline effortlessly as our workspace continues to grow. This has been a high-level overview of a React standalone project with NX, which as we can now see is just one configuration of an NX workspace that focuses on a single React application. It comes complete with the scaffolding that you might expect from a standalone application, but you still get the benefit of the full power of NX with this workspace. To sum it up, we saw how we can use the React Standalone preset option to initially scaffold this project with the npx create NX workspace command. We saw how we can use NX for code generation for both projects and components inside of our workspace. We saw how NX determines a project graph from imports based on our actual source code, and we saw how we can run tasks with NX, and finally we saw how we can define and configure task pipelines with NX to dynamically scale our task pipelines for our workspace going forward. If you enjoyed this video and want to learn more, be sure to check out nx.dev for our docs site, and check out our YouTube channel as well for more videos on interesting concepts and topics regarding NX.